This video is an overview of lesson 3.2, which is all about measures of variation. This is the second section in chapter 3, which is all about describing and comparing data. And this is from the Essentials of Statistics text, 6th edition by Mario Triola, based on slides provided by the publisher of our textbook, Pearson, and then modified by me for our course. So we've got 5 learning outcomes this time. In our first learning outcome, we're going to talk about measures of variation generally, and then talk about how we compute 3 measures of variation, including range, standard deviation, and variance, and we'll discuss the properties of each of those. And then we'll describe the difference between biased and unbiased estimators. Then in our third video, we will apply the range rule of thumb to estimate measures of variation or interpret measures of variation. In our fourth video, we'll talk about the empirical rule and its application when appropriate to approximate the percent of data values within a given range. And then finally, when appropriate, we will use coefficients of variation to compare sample variations from 2 different populations. So here's kind of the big picture. I've got dot plots for 2 data sets right here. Do you notice anything about them? Do you notice anything that they have in common? I hope you said that the mode for set number 1 is the same as the mode for set number 2. Set number 1 has a mode of 40. 40 is the value that appears the most. You can tell that it has a frequency of 4 in set number 1. It has a frequency of 2 in set number 2. So they both have the same mode. It's a little less obvious, but if I were to take each of these dots and write them down as the corresponding data value, and then add them together and divide by the total number of values, it turns out that the mean of set 1 is exactly the same as the mean of set 2. Even more surprising is that the median of set 1 is equal to the median of set 2. So both of these data sets have the same mean, median, and mode. They have the same center, but they're still different, right? The data set on the left has all of the data sort of concentrated. It's all between 38 and it looks like 43. All the values are between 38 and 43, and most of them are a little bit left of that 40 line. And then over in set number 2, the values are more spread out. But the measures of center that we talked about in the last section wouldn't tell us any of that. The measures of center for both of these data sets are exactly the same. So we need to find some way to measure the difference between set 1 and set 2. And that's when we talk about the measures in this section. This characteristic of spread, so how much those data values are spread out. Sometimes it's called dispersion, or sometimes it's called, as it is in the title of this section, variation. It's so important that we develop measurements of this idea, and we're going to talk about 3 of them in this lesson. Now, if you're thinking to yourself, why is the spread of something, why does that spread matter? There's a great example in the textbook where they're talking about wait times at a bank. And they say, yeah, even if you have the same mean, median, and mode for your wait times at a bank, if there's huge variation, if you're a customer and you don't know if you're going to wait just a little bit or if you're going to be waiting a really long time, that's worse than if you pretty much know what you're going to get if there were less variation. So in business, they often want to minimize that variation as much as possible so that people know what to expect, and because people know what to expect, they expect it, and then they're less likely to be disappointed or upset. In business, they often want to reduce that variation. And the first example that I think of when it comes to reducing variation is like thinking of Starbucks. You might say there are better places to get coffee, according to some people, but one thing that you can count on for Starbucks is consistency. No matter where you go throughout the country, you go to Starbucks and you order a latte or something like that, you're pretty much going to get the same latte in New York or in Tulsa that you would get in Florida. You know exactly what to expect at Starbucks. So they have reduced the variance in the way that they make their drinks because they've made them all kind of the same. They all sort of apply the same formula in order to make that latte for you. just for example. So reducing variance is a good thing, and measuring that variance is important. It's important that we be able to measure this, and that's what this lesson is about, is the ability to measure variance. Okay, so our key concept is about measuring variance. This is actually directly from the original slides from Pearson. It says, variation is the single most important topic in statistics, because when you measure something, when you have data values, they vary, and we want to capture that variance, or that variation, excuse me. We want to measure it. So according to the author of our textbook, Mario Triola, he says this is the single most important section in the book, because variation is the single most important topic in statistics. Data varies, and we would like to be able to measure that and talk about and describe that. And that's what this section will allow us to do. Specifically, we're going to measure variation with three measures of variation, excuse me. One is the range, another is the standard deviation, and the third is variance. And then, of course, as always, throughout the entire course, this is true. Our focus is not just on computing these numbers, but it's also on developing the ability to interpret and understand them. So we're going to interpret these measures of variation and understand these measures of variation using the range rule of thumb and the empirical rule in this section. So that's what's coming. And that is our lesson overview. See you next time.